Hi all, I'm a Standard 2 senior marker. My name's David Gale. I'm a teacher at St Augustine's College. So just going to run through the positives and areas where students could improve for the sections that I marked in the HSC. So the first question, so I broke all the common questions I've joined together. So question 13 in Standard 1, which is equivalent to question 18 in Standard 2. So this was a real life question in the sense of basic fuel consumption. The better responses, students realised when to multiply was needed and when to divide in order to calculate the fuel cost. Rounding was never executed at all until the end. And there was always just a really progressive, neat way of setting out their answers. Candidates are encouraged to realise the need to multiply the cost per litre rather than to divide by it in order to calculate the fuel costs, and think about what they are performing as a calculation. The big thing I found about, or we found about this question, was that, you know, many students actually have their licence in year 12, but they're not actually putting this question into actual real life situation. And I'd really emphasise and encourage teachers actually really to do that. You know, for instance, you know, some kids come up with an answer of $15.15, and it seems like there's no relationship there for a student actually to write that answer down when they're actually travelling 1,560 kilometres. Everyone knows at the moment, and under the current climates, fuel's, you know, $1.50 plus, and that just almost common sense analogy, it just doesn't add up, but students are still writing incorrect answers. Question 14 was a Standard 1 only question. This again was a inflation question. So in better responses, students understood the formula for inflation or compound interest. They calculate the values based on their formula correctly. They apply repeated percentage change if they didn't use the formula, okay, and they converted 3% and use it as a fraction or a decimal. Candidates are encouraged to know how to calculate using, using the power button on their calculator. Some students actually just, you know, rather than using to the power of 5, they actually just multiplied by 5. Know that the compound interest formula is related to inflation. Question 15 was the Standard 1 question. Question 20 was the Standard 2 common question. Obviously, this is a latitude and longitude question. In better responses, calculation the required time using longitude. So students clearly knew that longitude was in reference to time. They calculate the time difference, okay, by dividing by 15. Many students actually drew a timeline to give them a visual, okay, which is really important to see whether obviously Australia's forward in time in compared to Sweden. So candidates are encouraged to understand that only longitude difference is relevant here in reference to time. Understand why dividing by 15 is used, obviously to give us our hours. Adding time to given time accurately. Reading the question carefully, I can't emphasise this enough, and also too, really encouraging students, possibly if this is a 3-mark question, we're really try and break it down into 3 steps. So some students just threw this in the too hard basket and then it ended up with 0 because it was a non-attempt. But I think if we can actually really work on actually encouraging students to break it down, many students would be able to achieve a one mark, e.g. incorrect longitude divide by 15 to get the 1 mark, or adding of the longitudes, even though that's incorrect, but possibly could get 1 mark, subtracting the longitudes to achieve 1 mark. So effectively what we're trying to do is encourage that a student might not have success there of getting 3 out of 3, but they're actually, doing 1, 2 or 3 steps to actually get 1 or some marks out of 3 marks. And lastly, obviously, a huge amount of candidates actually subtracted the 9 hours from Sweden and went the wrong way. So I really want to emphasise with our candidates in the future, maybe actually emphasise the fact of doing that timeline where, you know, students actually can visually see that Australia is ahead of time of Sweden to obviously then add the 9 hours to the time difference to get the correct marks. So question 16 of the standard 1 paper, algebra question, rearranging the subject. Look, disappointingly, I think a lot of kids found this hard. In conversation with the chief examiner, he actually thought it was going to be much more straightforward for the candidate than what it was. In better responses, students knew to subtract 10 from both sides of the equation correctly. They then divided both sides by the equation by 2 and recognised that the multiplication connected the coefficient and the pronumeral R. Candidates are encouraged to understand what a linear equation is, really emphasise the fact that 2 sides of the equation to make one side, to make R the subject, we need R on one side and other values on the other. Knowing that changing the subject of a formula is not the same as substituting values into the formula. Having a sense of how to do the same operation to both sides of a linear equation. As a marker in the marking scheme, we were incredibly generous here on what we did to try and reward marks. Originally, we had a lot of students achieving 0s and 2s, so we opened up, you know, any indication that a student was actually trying to get R by itself and remove the 10 to the other side of the equation somehow enabled students to achieve 1 mark there. Question 20, standard 1 paper. Look, on the whole, this was, you know, really well answered, both parts A and B here. Better responses, they found the probabilities by considering the sample space. Students that actually, you know, achieved those responses clearly wrote out a sample space further to what the sample space already was given in the question. A lot of students use 1 minus the probability argument to correctly achieve part B. Candidates are encouraged to understand the probabilities lie between 0 and 1, understand the idea that the probability of an event can be calculated as the number of outcomes favourably to that event divided by the total number of possible outcomes. When all outcomes are equally likely, and knowing how to apply these in simple contexts. As I said though, look, many students here achieved 4 marks for this question. Question 17, so this is now just the standard 2 component. Okay, so 5-number summary, you know, kids had to actually find the interquartile range, multiply that by 1.5 and then added that to the upper quartile and get a result of 19 and hence, you know, justify that 20 was an outlier. So students that the better responses efficiently calculated the bound for the outlier and gave a conclusion. Okay, calculated the interquartile range. Students are encouraged to understand that just because a 5-number summary is given, this does not necessarily mean that a box plot should be drawn. Understand how an outlier is defined in this course, understands the outlier formula. Many gave lengthy answers which had some vague connection to the idea of an outlier, but were not consistent with the definition used in this course, knowing the difference between range and interquartile range. And I would also really encourage that, you know, some students think that they're going to write an essay for a 2-mark question and that's going to receive marks. Really emphasise to your student, for every sentence they write, it needs to have a mathematical statement with a justification and that's worth 1 mark. Hypothetically here, if this was worth 3 marks and there was a mathematical calculation and then there was justify 2 reasons why this would be, for each statement, have a mathematical statement that is different, because then it's going to get additional marks. Question 18, standard 2 common, so I won't repeat that, I've already gone over that. Question 19, it was a standard 2 question, it's a depreciation question. So in better responses, and look, on the whole, this was very well answered by standard 2 candidature. On the whole, in the better responses, calculate the initial value accurately without use of a formula, but from general reasoning. Use the formula for straight line depreciation and correctly solve the initial value. Work backwards through the problem and starting at 7,500, apply the repeated addition to get the answer. Students are encouraged to really find out the definition and the meaning of initial value and what salvage value is, and also really understand what the straight line depreciation formula is and what the declining balance depreciation formula is, and obviously which to use and when. Solve a linear equation correctly for an unknown variable and rearrange the formula, which caught a lot of students out, just of actually what to do. For instance, many students, $7,500, they actually subtracted the 5 by the $2,300. Question 20 was, which I've already gone through, was a standard 1, standard 2 common question, so I won't repeat that. And question 39, okay, so again, 2-mark question. On the whole, I thought that this was well answered. Just talking off the cuff here, there were some students that struggled with that. There were 2 questions related to 2 different triangles. You know, and I want to emphasise, in consultation with the chief examiner, they actually highlighted this first triangle, you know, and shaded another triangle so students would see the difference between A and B. In reference, in better responses, students found the angle by inverting the area of a non-right angle triangle formula. They applied the cosine rule to find a side length. They read the question carefully and followed the instructions about fencing needed and retrieved a result. Candidates are encouraged to realise that right angle trigonometry can only be used with right angle triangles. Realise that a triangle may appear close to right angle, but that it not can be assumed if it's not a right angle just because it appears that way. Okay, know how to use the area of a non-right angle triangle formula and how to rearrange it to find the angle included between 2 sides given with the area. Understanding the radial diagram given and how the bearing relates to angle sizes in the triangles.